Oh, this is old electronics fan, and hiding behind this meter right here is my Philco Butterfly radio. And it's called that, if I can get my case in here, because of the design, and I can't get it, there we go, because of the design of the case. This radio has been in the process of being refurbished for quite a while. Well, you know how it is. You get a project just so far, you run into issues. This, by the way, this speaker belongs to that radio, and you just happen to buy another radio, and you're really anxious to get started on that other radio. So this thing winds up sitting in the background, and you go and work on this other radio. So I have made a decision. I'm going to try to finish these abandoned projects. Number one, I'd like to have this back together and working. I'm unfortunately quite a ways away from doing that, but I am working toward that. Now, this is a field coil speaker, and this is one I bought from one of my radio club members. So I was looking for a replacement for this. We'll get back to that one in a minute. And he had this. Now, what's challenging about dealing with vintage speakers is that they weren't exactly what you would call consistent in the sizes of their speakers, which is one of the things that makes it very difficult when you're trying to find a replacement surround for one of these. They don't match up very well with what's available. This speaker is 1.5 inches, or 6.5 inches rather. This one is 6. So, and it wasn't originally designed for this radio. So I wound up drilling new holes, because the other problem is that this has to fit between the two tubes. There's a tube on either side of this thing. The tube on either side of this. So I can't have it poked around, turned like that. So I went through all that trouble, put it in the radio, and my friend from the club had marked the pins, and I didn't. I looked at them, I kind of knew where they were, but once I had this in the radio, this part was hidden. So I thought, well, I will figure out, easy to do, let's find out which pins are which. So I got down here, and sure enough, I've got 5 ohms, which actually I think this one's, just for fun, let's see what this one is. This one might be a lower ohm speaker. Come on. It's another thing, they don't. 1.2 ohms. So this is a much lower ohm speaker. But anyway, this one would work. Then I went up here. These are the two field coil connections. And I went like this. And you notice something. My meter says nothing. I couldn't believe it. He had this on his bench. He had tested it. It worked. Then I came and got it and brought it home. And the only thing I did was try to mount it into the radio. I had not applied power to this thing yet. And yet somehow between his house and my house, this thing stopped working. So the question is, what happened? And another question that follows right behind it is, what do I do now? Well, I had dug this speaker out of something else that I had, and I thought it would work. I did not realize what shape it was really in. And I'm going to see if I can salvage it. The surround in this has cracks all over the place. And that's purely from age, because until I took this off its mounting board. I had not done anything to this. This had not been removed from the board ever. So why I've got all these cracks, the only thing I can guess is its age. I mean, the actual cone itself looks fine. So I'm going to use some rubber cement around the surround to fix the cracks and prevent it from cracking further. I may still use this for testing. This speaker does work, but I wasn't entirely sure I wanted to use this. So I went back to my friend at the club and I said, do you have another speaker? And this is a Utah. And this is also a field coil speaker. And but I think, be careful with this, but I think this is also a bit larger. Yep. This is also 6.5 inches. And the problem with that, aside from the fact that it's bigger, which normally I'd love that because, you know, a bigger speaker is probably better sound. But the problem with that is that this radio, oh, stop doing bad things to my face. This radio was designed, let's tilt you up. Let's do this. The radio is designed, it basically goes from here to here and from here to here. And there's very, very little room for putting something that's not exactly the right size. I did measure, and I was fairly confident that this 6.5, I could make the 6.5 inch speaker fit. I'm heading in two different directions in my brain, and it's not good. Okay, I realize I've just switched from one thing I was talking about to suddenly talking about some other thing, and what you saw me doing was, and this is a voiceover to try to fix my broken videoing. What I'm doing, in the process of doing, is I'm taking the old speaker and hooking up the field coil from it to the radio it came out of. The problem I'm trying to solve is that I never actually measured to see what the voltage across that field coil actually is. And I realized that was a mistake. Fortunately, I guessed correctly what the voltage was. I was within like 15 volts of what it should be. But I hadn't checked. And I also was curious to see what kind of current was flowing through it. The reason for that was because I was a little bit concerned, given that the two speakers from that club member, both of them had field coils fail, and I was wondering why that might be. The other thing is that the wires leading to the field coils of those speakers are thinner than the wires for my my old speaker. So I'm wondering why that would be. So right now I'm showing that, yes, I've got this hooked up to the radio. That meter is going to wind up hooked up in series so that I can read the current. I've hooked up this test speaker to the output transformer of that radio. Then, I'm not sure what I'm pointing to, but what I'm going to do now, what I am going to do is that meter to the right is going to be hooked up to read the voltage across the field coil. I'm talking about phases. And then the other speaker, or the other speaker, yeah. I will probably get into phasing later, since I screwed up this recording somewhat badly. So, so again, this is new territory to me. The club member was only testing the field coil speaker at 30 volts. He was reluctant to go any higher than that. I had a feeling he knows that the coils run at a higher voltage than that, but for whatever reason he wasn't really wanting to go above that. So that made me a bit concerned, especially when I saw that the wires going into the field coil of the new speaker that I just bought, which I'll show you in a minute, and the old speaker that had a failed field coil, those wires were a lot thinner than what you see here in this older speaker. And I'm thinking, if I had to guess, I think this speaker you see here is probably about 10 years older, but this is just kind of a wild guess on my part. But you'll notice that when I get around to actually repairing this speaker, this has a different style spider. The design, it doesn't have a felt cap over the voice coil area. It's an older speaker, quite a bit older actually. So anyway, so I want to know, just from my own information, what kind of current is flowing through these and what kind of voltage is across these. Now, I almost screwed up big time, and I'm just going to let you know, just so that somebody in the future could avoid doing bad things to their field coil speaker. And maybe somebody else wouldn't make this silly mistake. But my mistake that I almost made was thinking, oh, there's almost 300 volts on the plate of the output tube, which this field coil is connected to. So therefore there's 300 volts on this coil, and I should be able to run it at 300 volts. Thankfully, I didn't do that, because that would have smoked that field coil in a heartbeat. Gotta stop and think when you're doing this stuff, and start thinking about, okay, what does Ohm's law tell me? Just think about basic stuff. When you have a resistance in a circuit, it's the current through it and the voltage across it that determines what kind of voltage is going to be dropped across the coil. So in this case, there is indeed probably, let me think. Well, let's just see what we come up with here. Alright, so I'm hooking up my meter so that I can read the voltage across the existing field coil the field coil that came out of this radio. I want to know what that is. So in a moment that will come up. So since I'm redoing this part, I know that the voltage across the coil is 80 volts, and the current through is 66 milliohms, or milliamps, I mean. So what I can calculate from all of that is there's probably, well, let's think. So you've got 270 volts and 80 volts. So that's okay. So that's 350 volts coming from the power supply, and so you've got 80 volts dropped across the field coil resistance, which gives you the 270 volts that you have at the plate of the output tube. And that's the kind of thinking that I should have been engaged in when I was thinking about what kind of voltage I should apply to my field coil, and I almost didn't. And I certainly should have measured to make sure of my numbers before I ever hooked up that field coil speaker to my separate power supply. So I think at this point I might scoot ahead. Well, let me just wait. Let's just wait and see if I gave you the right numbers. Oh, the other thing that I'm going to do here is I use a variable transformer, isolation transformer, whenever I'm working with this old electronics. And whenever I'm wiring something up like this, one of the things I want to know is, did I wire it up correctly? Well, how do I find that out? Well, I review my wiring before I apply power to it. I double check it, but you can still make a mistake. You don't think about something right, you miss a bad connection. So the next thing you do is you bring the voltages up slowly, and you start looking. In this case I have meters to tell me. You start looking at those to see if the numbers that you're getting on the meters make sense. And if it doesn't, then you need to stop and double check and see what's going on. And so you see voltage coming up on that meter to the right. And by the way, it's saying minus voltage because I was pretty much guessing which way the meter should be hooked up across that field coil. Maybe if I thought about it enough, I would be able to say, yeah, it has to go this way. Yeah, and I probably could, but I didn't take the time. I just hooked it up. So yeah, so once the radio warms up, I'm actually at 80 volts and somewhere around 67 milliamps worth of current. So does this help me when it comes to the new speaker? Basically, it's kind of a universal replacement because the transformer in it, which you will see, has multiple taps on it to allow you to hook up that speaker in a variety of different radios. Now this radio runs at pretty high voltages. So, in fact, I don't know offhand of any radios that run at any higher voltages than this. So, I probably shouldn't have been worried about toasting the field coil of the replacement that I was going to put in. Because I'm sure that they had to know if this is a universal speaker designed to replace other field coil speakers, it would have to be designed for these radios that run at high voltage. Newer radios run at lower voltages, and there's the new speaker. This is a new old stock speaker, by the way. It's brand new. It's never been used. Like I said, it comes with a universal output transformer, which I'll probably use somewhere along the line. Nice to have anyway. If I should happen to get a radio that has a toasted output transformer. So my club member was worried about testing above 30 volts. At least it seems he was. You look at the wires on this, the black and the yellow that you see here. Those wires are a lot thinner than the wires that you see on the voice or the field coil of this old speaker. I was wondering why, and it made me concerned. So, anyway, at this point I'm just removing the one of the leads is going to the speaker itself is still connected to the output transformer, and I'm removing that. So I can actually hook this speaker up, because what I'm going to do is I'm going to test this speaker and make sure it's going to work, but I'm going to do it first of all by hooking it up to, remember, I think I actually did use my little power transformer that you see to the right there, I believe. Oh no, actually I know what I did. I used my alright, let me back up. I'm going to test this speaker using my DC power supply, which by the way is one of the ways you can test your field coil based speaker. You don't have to have what I had there, that transformer that will put out a whole lot higher volts than that will. You can use, for testing purposes, you can use a 30 volt DC power supply. That's what I set this one to. I think it will go a little higher than that. 35, 36 volts, something like that. But anyway, maybe even higher than that, I don't remember. But in any case, you can test your field coil speaker using your DC power supply, and it will work. But to actually test it for real, once you've made sure that it is working, you need to have the coil running at the voltage that it would normally operate at in the radio. But at this point, all I'm doing is I'm just making sure that the speaker is indeed working, that the field coil is good, and with it all as well. And in this instance, this field coil draws 30 milliamps. We've already seen that the field coil in my old speaker is drawing 66 milliamps. And of course the reason for that is that it's running at 80 volts. It's dropping 80 volts across the coil. So when I put this speaker in this old radio, there will be similar numbers. That's going to draw similar current, although not exactly. We'll go into that shortly. So at this point, I think I'm going to bail out and go back to the video as I recorded it. I'm not sure what comes next. Just bear with me. It's a Utah Radio Products Company, Chicago. There it is. And this is designed to be a universal speaker. 3 to 5 ohms. Right, so what we got to do, yeah, this does have a lower ohm speaker. I don't think that's going to hurt it. It'll go off by a couple of ohms. Actually, I want to use a different pair of pliers. Yes. Alright. Or maybe I don't. I'll see. Alright. So let's pry you out a little bit. Yep. Come on. There we go. Let's go. Let's go, please. There it is. Alright, let's go over here and bend this back because it doesn't seem to want to come. So we'll just persuade this to go where we want to. There we are. There we are. Okay. Alright. This is going to be, well, there we go. This is going to be handy to keep around, so I'll have to find a good spot for that. I'm going to put it in the speaker box with the little chart. Oh, that was not nice. This box has been opened a few times. I just dropped the transformer in it while I was holding this, and it came off. Rats. Alright. Let's see, put our chart in there. Maybe my friend will have an explanation for what the chart means. Alright. So, alright, let's go with this. I want to go to ohms. Disconnect that and that. Because what I want to know is what I have to do. I want to make this about 1200 ohms. That's what I'd like to do, I think. Alright. It's 0.98. So around 300 ohms. Well, maybe, let's see, I've got a high current, although I probably don't need a high current. But let's see what we got here. 50, 10 watts, 200 ohms, there it is. Let's see what that gets me. Doesn't have to be exact, I don't think. There we go. Of course, that's going to be a pain. I got to figure out how that. I'm going to put that resistor. All right. So let's see. Let's see what we have. No. Don't do that. Alright, put you down there. The wires don't want to cooperate. Please cooperate. Alright, got you there. There. You go there. You go there. Whoops. Stay. 1180. Well, that's almost exactly what the other voice coil was. I think it was like 1167, or yeah, something like that. 1180. All right. So, do I really need to do that? I am not sure. Now I'm using a high watt resistor, but given that it's only 50 milliamps, I don't think I need to worry too much about having a high current resistor there. Not bad. Let's see. Let's bump it up some more. That's about 120. And now we're at 80 volts, 66 milliamps. That doesn't feel too bad. That's barely getting warm at this point. So my only concern though is that the speaker may have been designed for something that maybe operated at lower voltage through the field coil. And one of the reasons I was concerned was because the guy I got the speaker from was not inclined to test it over 30 volts. This is now running at 81 volts and 65 milliamps. So I'm going to have to do a little Ohm's law action here, or calculation here, and figure out what the current is that's flowing through it. Because right now, my that 10 watt resistor is getting kind of warm. So, yeah. I probably don't want to make that 10 watt any smaller. If I go down to like a 2 watt, that might not cut it. I'll have to think about that one. Well, I've got to do a little calculating. So anyway, so it looks like this speaker is going to work. One of the issues that I'm going to have though is getting this mounted. And that is definitely going to be a challenge. I think I'm going to let this thing run for a while, and I'm going to do that off camera. Because there's no need for me to keep recording such exciting footage as watching me check the field coil every so often. I'm sure that would really be a ratings boost right there. Not. So what I'm going to do is I'm going to let this run for a while. I'm going to check on it and see how it's doing. And then once I'm sure that I'm happy with this, my next step is going to be making this fit this. And as I said before, here's the speaker. The way this was mounted so that this is up. This was straight up and down, like this. And there are two holes right here that were specifically for this radio. No other speaker matches the positioning of these holes that I've been able to find. If you look at this, try to line this up, you discover something. That's one hole. I've got it lined up here. It winds up here. instead of being down there, which would have been so nice, it winds up here. And the other problem I'm going to have is that this thing is heavy. And they've got it mounted on rubber, I guess you can't see, can you? Well, let me show you. Yeah. And, alright, well there's one of them. There's one of the mounting screws, and it's rubber mounted. And so the other problem is I've got this tuning dial right here. Oops. I've got this tuning dial right here. Like it lines up right there. When you mount a speaker in here, if the speaker is just slightly wider than the one that came with it, it's going to want to rub on this. Oh, and as I was saying, this thing is heavy, this coil. This one's lighter, but it's still not light. So what they did was two rubber mounted, mounts here, and there's a hole there. It's threaded. There's a rubber mount that screws into that, which supports the back end of this thing to keep it from going that way. So what they did was, this is going to mean I have to come up with a nut for this. So what you do is, you put this up through the bottom of the chassis, put this part on, and then you screw this into the frame of the speaker. So I'm going to have to come up with a nut to fit this. Hopefully I can make a bracket to come up and over and mount this. So, no. Yeah, it's still playing music, so I really can't let that play loud. So that's my next step. I got to find a nut to fit this, and I've got scrap metal I can make a bracket from, and I can weld it or mount it to the back of the speaker with JB Weld. If I were really brave, I could tack weld it, but I would worry that despite my efforts to protect the speaker, that something would escape, go around, hit the paper cone and burn a hole through it, which that would not be exciting. Well, it would for a minute, especially if it caught the cone on fire. Then it'd be really exciting. So, alright, so I'm at this point, I'm in just, yeah, it's getting warm, but it's not terrible. This is about how warm the other one got when I was playing with it. I think, in fact, when it got this warm, I actually backed it off to like 65 volts because I didn't know how warm it was supposed to get, but I think this is okay. So what I'm going to do is I'm going to shut the camera off right now. That will allow me to turn the speaker up. I don't think it's going to matter in terms of the heat from this coil getting greater, but I want to play. I just want to let it play, and I want to see what happens, and I'll get back. I'll come back. Probably what I'm going to do is, if I'm happy with the outcome of this, my next step is going to be figuring out where to put the screws to mount this thing. And I have a nasty feeling, given there's very little room between the two tubes that sit behind this, what's probably going to wind up happening is you notice that the I've got a screw hole here, and I've got two way out here. So if I decide to use this one, this thing is going to tilt, and I would really like to be able to do that. I really would love to do that. So that means I only have to drill one hole. But I don't want that frame riding against one of the tubes. Well, anyway, I'll get back to you. Okay, I didn't show you everything I did to get to this point, but I've got both holes drilled. One thing I got to show you over here, when I pull the speaker forward to where I really want it, it actually touches the tuning mechanism. I let it drop back, there's clearance there, so what I'm going to have to do is I'm going to have to leave it like that, and you know, maybe just adjust my rear bracket, which I got to make yet, just enough so that it's clearing. Oops. And something else I did, I was experimenting a little bit, and I decided to see what would happen if I didn't use a load resistor. Come on. A load resistor, this 200 ohm load resistor, to make up for the fact that this field coil is not exactly the same ohms. So what I did was, so I hooked it up directly. I hooked up my meter for the current at 67 milliamps instead of 65 or whatever it was. This is slightly higher. The voltage over here is 72. It's about 8 volts, thereabouts, 8 or 9 volts lower. At this point, I don't know. Actually, I should probably check the plate voltage on the output tube. Except I think I'm probably there. Let me just check. Alright. Let's see. Actually, let's look at the meter. Or let's not look at the meter. Let's look at the schematic, because I'm measuring across the field coil, and the field coil is actually on this side of the, there's your output transformer, there's the field coil. So we're on this side of the transformer over here. So, and there's the plate right there. And so what I want to know is, it's a 42 tube. Let's see if I can figure out what the voltage, and do I have, I don't remember if the ground is common to the chassis. It might be, looks like it is. Yeah. Well, actually there's a capacitor there, so let's see. So that is right to ground. Alright, so, and that is that tube right there. And let's see if I can see where that connects to. Where is my flashlight? Yeah, I know that's not a complete sentence. Oh, here it is. Alright. Okay, so what I've got to do is I've got to see, and alright, so the white side goes to there, so then the black side goes over here, and okay, and that's the plate, and that goes right to that, the tone control. Yes, it does. Okay, so let's check this out. Alright. So let's see what we got here. So my tone control is here. Thing. 278. So I didn't check that before. That plate voltage seems pretty healthy. And that was a 42, I guess it was, for the output. Alright, so let's find out what my tube manual says for 42. for plate voltage. No doubt it's giving me a range. Somebody once said, if you give it to somewhere near what it wants, it'll work. Because the question is, does that mean it's going to work? Well, that is the question. The tubes are a lot less fussy about what they need than our solid state devices. Alright. Let's see. Type electrically identical to a 6F6. So let's find out what a 6F6 needs for plate voltage. 6F5, whoops. 6F7, and there's 6. Alright, so plate voltage, 375 max. Alright, typical operation, plate voltage around 250. What did I say this was? 270? Yeah. So, alright. I'm thinking the plate voltage is probably a little bit higher than it was before I put that field coil in. And the reason for this is simple. When you reduce the resistance of something, you also reduce the amount of voltage you're dropping across it. You increase the resistance, you increase the amount of voltage you're dropping across it. So my field coil was 72 volts now. It's dropping across that, which means there's 9 volts that's probably going elsewhere, which most likely means that this was probably originally around 270 volts. So 270, 278, I think that's going to be fine, to be honest. I don't think a higher plate voltage is going to hurt things at all. So I think that's what I'm going to do. I'm not going to bother with a load resistor. This load resistor, I'm going to leave it out, because I think I don't need it. And so the other thing is, I mentioned I was experimenting with a variable tone control. I'm probably not going to leave that in. I still have the original. Do I have that readily available? I don't know. Somewhere in this pile. Yes, there it is. Okay. It looks like a train wreck. But this is the tone control for this radio. And so what I'm going to do is I'm going to put this back together with the values that they suggested. I think this is a 0.2 or 0.02. I have to look at that. 0.02 I think is in there now. And it seems to work very well for tone control. So I've got to find the documentation that tells me what they originally had on these, because I got 1, 2, and 3. Whoops, yeah. So there are 3 capacitors in here. So I'm going to look at my document, wherever that is, and see what I can come up with. Anyway, so there's some work yet to be done to this, and once I get this thing working properly, then I'll come back and I'll show you what I've got and what I've done. Okay, I've made this little bracket. There's the rubber mount that was there for the original speaker, and you can see how much of a difference there is between the back of this speaker and the old one. So here's my thought, my plan. Let's see here. Okay. Alright, so this goes on here. goes and it rests on that. So if I turn this around, if I can. Alright. So yeah. So that holds that speaker. Yeah, I think that's back out here a little. So that holds that speaker. Come on. So that holds that speaker about where I want it. What I'm going to do is I've got a little clamp that I can use to secure this. And so my plan is to mix up some epoxy, put it on that little bracket, set the speaker on it, secure the screws, and then I'll clamp this into place until it actually cures. And hopefully then at that point I can put my radio back together and begin doing some of the other things that I want to do. This is one of the challenges of working with vintage equipment and trying to find speakers and such, especially when the speakers that came with your particular radio or whatever are non-standard sizes, and apparently that one is. Because it seems like a lot of the speakers, the newer speakers, that's an older one. This is newer. The other one that I was showing you, the other field coil, I think is older. Or, I'm sorry, is newer. 6.5 seems to be the size that they went to after some point in time. This radio is old enough that that was before that time. So, you gotta get creative, you gotta make things work, and this is how I'm choosing to do this. And with a clamp on here, I can probably then hopefully have a clamp that will fit in there. Do I have a clamp? And will it work? This is one of my clamps that I have, which I think is probably my best bet. Let's see. Yeah, that'll work. That will work. Alright, I think this is my only clamp that will work. I got 2 of these floating around here somewhere. Don't know where the other one went. I will have to go on a search. Darn. Anyway, these are extremely handy. I don't know, and these are old, but I've found lots of uses for these guys, and looks like I will be using them again. Alright, so I'm going to put this back together, and once everything's cured and ready to go, then I will go into the next phase, which is to put everything back together. And time to do the epoxy and put this thing together and see what we got. Because I won't know until that's all settled in, whether that's going to do what I want it to do. Really hoping it works, because once you put the epoxy on there, you're kind of committed. So anyway, I'll be back. Okay, well, as you can see, I have my speaker mounted, and my bracket worked. This clears this, not by much, but it does. It doesn't rub or anything. I've had it playing, there's no vibrations, all good. So, okay, well, I mentioned that I wanted to keep the original tone control in this. The problem is, I wasn't happy with the sound coming out of this radio. Okay, well, once again, I'm learning stuff. It's a good thing, but sometimes frustrating, but it's a good thing. This, let me show you these. I actually found this stuff kicking around. This is the tone control for the Butterfly radio, the Philco. And these pieces sat inside of this little tray. And you can see they were kind of potted in there. And it's not as hard as you think to get this stuff out, because it's kind of degraded, and I don't know what they used originally, but it wasn't that difficult to pull this out of there, and it did involve a little bit of heat, but not as much as you might think. Kind of it's just, and these are just, whoops, these are what you find inside paper caps. You've got insulating foil, or paper, I guess you'd call it. Then you got foil on one side of it, and then you wrap it around, and that's pretty much what makes up your capacitor. But anyway, not news for a lot of you. Here is the tone control for the Philco Butterfly radio, and it's got these fingers here, and their job is to, and this is one connection that I should explain. This is one connection, this is another connection, this is actually another connection. This is bolted to the chassis, which supplies the ground for this one capacitor. So this capacitor is always connected, and this is the capacitor that supplies the treble, I guess you should say. I could in this tone control. You got treble, which is this, then you've got mid-tone, and you've got your bass. And so as you rotate this, you get these three fingers. Well, you hit the first one, that's your mid-tone, and then you rotate one step further, and now you've got your bass. And this one here is intended to make sure that these two are provided with a ground. They don't rely on the shaft going through the housing, well, I suppose they could have, but they decided to make sure that you have a firm ground to ensure that when you switch to the different levels of tone control, that they are all they all work properly. Now, I'm thinking here. Oh, okay. So that's all pretty straightforward, and let me show you on here the diagram for this. And let's see, I want to go up here. I'm going to zoom in again. Oops. Focus, please. There we go. Alright. Now, this radio. I went hunting for the values that I should use in the tone circuit. And there are two versions of this radio. There's a console version and there's a tabletop. The tabletop is the 45, for those who might not know. The console version is the 29. Now, for who knows why, the tabletop version of this radio, the schematic, doesn't tell you what these values are. These values that you see penciled in here, 0.01, 0.02, and 0.003, those are what came in. Those are what came from the circuit diagram for the 29. This is the high frequency, or the treble. Like I said, it's always grounded, always connected. This is the wire that goes to the plate of the tube. If I move this up a little bit, you can see where it says output. That wire right there goes over here to our tone control. Now, I had this radio set up with these capacitors, and I didn't like it. I thought, that's horrible. How come they use those values? So then I came up with these values, 0.02, 0.03, and 0.01. Oh, and this 003 could, I think in some instances, I think I may have found it was 0.001 instead of 0.003. But I think these were the values that I was using, and I hated how the radios sound. So I came up with these. Then I put the radio in its case. for the first time in many years, and I realized I didn't like it, not a bit. So, what to do? Well, here's what I have done. Let me zoom back out. Alright, now, let's see if we can get a little bit closer. Alright, so this right here is chassis ground, which is what the circuit diagram is calling out. Over here we have this wire. This is the plate connection. This wire goes straight to the plate of the output tube, where it said output tube on the schematic I just showed you. So what I've done is I've set up 3 capacitors using the values that were called out in the circuit diagram. These 2 are the O2 and the O1 capacitors. So what I'm going to do is, first I'm going to turn it on, and then we'll see what the treble sounds like. Because like I said, I was not real thrilled with that when I tried that originally. Once I put this in the case, now I'm familiar with the fact that when you have a speaker in an enclosure, it sounds different than it does when it's out in free air. And in the last video I actually explained a little bit more about that. I did not realize how much of a difference that was going to make, in this case especially. Because I have played around with speakers and I have noticed a definite difference between in a case and out of the case. I didn't realize how much it would matter to this radio. If I had, I would have not gone through everything I did to try to find a capacitor value, only to find out the values don't work. Well, that does not excite me much. I wonder if I have an 001. Do I have? Let's find out. Okay. Alright. Now we will put you there. And do that. And let's see if that makes any difference. What happened? All of a sudden I just lost everything. Gotta check this out. Alright, well that was interesting. This capacitor was working for all of 2 minutes and then it seems to have gone south. I do use capacitors around, but I test them pretty well before I decide that I want to keep them. But this one seems to have gone bye-bye, because when I try to hook this up to the plate, it immediately shuts down the radio. So right now, let me think, what do I really want then? If I don't have an 003 that I like, I think what I'm going to do is I'm going to experiment a little bit more off camera. Then I'm going to come back and I'm going to tell you what I found and what I like. But this does give you a starting point, and you can decide for yourself what you like. So I'm going to try, like I said, I'm going to experiment. Hopefully I can get some other stations to play with. Our AC or AM reception around here is less than ideal. But so I'll be back shortly. Okay, I definitely experimented. I tried not having this one in here, the 003. That was much too noisy and much too bright or shrill. It wasn't great. And I wasn't entirely happy with how the other 2 ranges sounded without that in there. So leaving this in here, even if you don't use the treble setting, is a good thing to do, it appears, because it affects what happens with these two. So remember, you're adding capacitors together. So it looks like, based on this radio and my ear, that this is the right combination of capacitors. The mid-range sounds really good. Actually, this one, mid-range, sounds really good. It's helpful to have the extra capacitance on the bottom end if you have a station that's a little bit noisy. It might help deal with that to some degree. Probably most of the time this radio is going to spend, this radio is going to probably spend most of its time here in the mid position. But to get a good sound out of that setting, this has to be here. I tried an 0047, wasn't entirely thrilled with that. I tried an 001, wasn't happy with that. So I guess these are probably the best settings, and these are the ones that actually came from the Model 29 radio. So I guess they got it right, and I went through all this experimenting only to find out that they got it right. So for those of you who want to at least have a starting point and you can decide for yourself what works for you, to me this does not work. The 02, 03, 01 that I started with, that just doesn't cut it. And if you're trying to evaluate this with the speaker out of its case, with the radio out of its case, don't do it, because you'll be very disappointed when you put it back in, because it won't sound nearly the same as it did when it was out of its case or not connected to the speaker in the console. So just that little word to the wise there. When you're playing with this stuff, have the radio together, have the speaker positioned where it's going to be, depending on doing a desktop radio or a console, because you're going to be fooled if you don't do that. So now I know how I'm going to wire this up. I'm going to wire it up, put it back together, and then we'll go from there.